fractions, decimals, and percents have a couple things in common. They are all part of a whole. They all have an equivalent counterpart, which means every fraction has an equivalent decimal and every decimal has an equivalent percent, etc. And all of them can be greater than one whole. Any fractions that are equivalent have the same equivalent decimal. And any fractions that are equivalent have the same equivalent percent. An example might be that 1/2 is equivalent to 3/6. Well, the decimal to 1/2 is 0.5. That means the decimal that goes with 3/6 is also 0.5. Their equivalent percent is 50%. So although the digits in a fraction may change, the percents and the decimals do not. We watched a video in class that talked about being able to change fractions to decimals, and some of the things that you learned were that there were different denominators that you could look for in different tricks. I'm going to do a real quick review of this. Tenths, hundredths, and thousandths. These denominators, when being written as decimals, we're going to use the place value chart. So because this says 4/10, I'm going to put a 4 in the tenths place. And because this is 9 3/100ths, I'm going to put a 3 in the hundredths place and a 9 as a whole. 87 thousandths means that the last digit I should write should be in the thousandths place. The relationship between denominators and decimals should be that the zeros match the digits. 1 0 means 1 digit behind the decimal. 2 zeros, 2 digits behind the decimal. And 3 zeros, 3 digits behind the decimal. Some other fractions that you might easily convert are 1/2. Anytime you have a denominator of 2, your decimal is going to be 0.5 or a whole number, which is 0.0. So this one would be written as 0.5. And this one, when I convert 7/2, when I think about 7/2, I know that that's 3 wholes and 1/2. So this would be written 3.5. When the denominator is fifths, I want to use the part of 1, or the name for 1, 2 halves to make tenths. So when I have this 1/2, I could multiply it by 2 halves, and 1/5 is equal to 2 tenths. And now this becomes a decimal that I can write using my place value. So 1/5 is equal to 0.5. And 3 4/5 is equal to 3 8/10, because I would use this form of 1. And so 3.8 are my equivalent decimals. Let's go here and think about money. Fourths. We're talking about quarters because it takes 4 quarters to make a whole, because it takes 4 quarters to make $1. And sometimes when you think about something you're familiar with, such as money, the answers seem to come easier to you. So 3/4 would be 75 cents. And 6/4 might require me to turn it to a mixed number and understand that 6/4 is the same as 1 whole and 2/4, which I know 2/4 is equal to 0.5 because 2/4 is equal to 50 cents. 3/20, I think about nickels because I know it takes 20 nickels to make $1. This I might read 3/20. If I'm thinking about converting it to a decimal, I might read it 3 nickels. And 3 nickels means that I would write 0.15. Now, what if I used the same strategy and wanted to turn this into 100? Well, I could do that by using a form of 1 known as 5/5. 4 19/20 makes me think $4.19, which is 1 nickel away from being a whole. The next whole would be 5. So this would be 4.95. about eighths, I'm thinking about half quarters. Miss Prophet explained this in the video about how half a quarter is 12.5 cents. So 1/8 would be 0.125 because 1/8 is 1/2 of a quarter. 2/8 would be a quarter because that was equal to 1/4. So 1 3/8 is 1.375. Ninths are my favorite denominators because they're always the repeating of the numerator. So this decimal, 0.1 repeating, is 1/9. 0.2 is 2/9. 0.3 is 3/9. 0.4 repeating is 4/9. 0.5 repeating is 5/9. 6/9. You get the idea. If you look here right under thirds, well, 3/9 is equal to 1/3. So that means that this decimal is also the decimal for 1/3, 0.3 repeating. 2/3 is the same as 6/9. So 2/3 is 0.6 repeating. These are some other denominators that could easily be multiplied by a form of 1 to have a denominator of 100 so that we could then use our place value strategy. And it's really important to remember that anytime your denominator is 1, then your decimal is a whole number. So if I said this were 5 wholes, my decimal would be 5. Some people may say you need to write 5.0, but 0.0 doesn't add any value and is really unnecessary. So sometimes decimals are written as whole numbers because there is an understood decimal at the end of every whole number. So we have all of these different ways to remember, and you may be feeling overwhelmed. Some of you are really good with memorizing things, and this would be your strategy, to memorize these. Others are like, what do I do every single time? Well, have no fear. Mrs. E wrote a song. I'm a little fraction, short and stout. Here's what I'm called and here's my amount. If you need a new name, have no fear. Just tip me over and divide me out. It really is that simple. The fraction, the numerator, goes on the inside. 2 n's. Num, inside. So the numerator is on the inside. Adding a decimal and 3 zeros is good practice. Sometimes you'll need 3 zeros, sometimes you won't. Sometimes you may need a little more. 1/12. I'm going to divide. How many times does 12 go into 10? My decimal goes straight up. How many times does 12 go into 100? 8 times 12 is 96. 4, bring down my 0. 3, 36, 4. At this point, I've realized I have a repeating decimal. Terminating is when it comes to a nice even remainder, or a remainder of 0. I'm going to erase this so we have room to do these others. Tip me over and divide me out. 4 is your numerator. 4 goes on the inside. Both start with n. Both have an n in them. Excuse me, they don't both start with it. Again, you don't always need 3, but that's a good habit to get in. 8 into 40 is 0.5. 0 is my remainder. I know that I've seen this decimal before, and perhaps it's because if I simplified 4/8, I would get 1/2. Equivalent fractions have the same decimal. Tip me over and divide me out. This is obviously a repeating decimal, and if I remember, anytime it's a 9th, it's a repeating numerator, so 0.3 with a vinculum across it is a repeating decimal. Well, what about an improper fraction? Well, tip me over and divide me out. Because this fraction is greater than 1, I must have a decimal greater than 1. 1 4/10.